good.
No,
Okay,
right there.
factors and prime
I learn
factorization.
better when I see it.
Listen, we're gonna talk. You okay?
Yeah. Bless you.
Okay, we're gonna talk about factors and prime factorization. What is a prime number? Does anyone remember?
Oh,
I have
mine.
no clue.
Odd numbers, odd numbers.
Not odd numbers.
One.
Even numbers.
Nope.
I don't know.
What?
In between numbers.
No factories.
I'm guessing.
What does that mean? It has no factors. It does have factors, but it only has two factors.
feel
What are the
sad.
factors?
Oh, what is?
Is it like 1 times
Yeah,
2?
one time. No, Caden's right.
What does
It's
it
one
mean?
times itself. It's
Oh.
numbers that only can be
Sorry.
multiplied by one in itself. Okay, one in itself. A composite number. What is a composite number? Does anyone remember? It is a whole number. Okay, a whole number. It's a whole number that is greater than 1 and has more than 2 whole number factors. It is greater than 1 and has more than 2 whole number factors. Okay. So we have prime numbers and composite numbers that we're going to focus on today. Prime numbers are whole numbers, a whole number that is greater than 1 and has exactly 2 whole number factors like 1 and 3, or 1 and 2, or 1 and 7, okay? Those are all prime numbers. A composite number is a whole number that is greater than 1 and has more than 2 whole number factors, like 6. 6 is 1 and 6, 2 and 3, okay? 8, 1 and 8, 2 and 4, 24, it's got a big list, okay? So let's look at this word problem first. You are working on your school yearbook. Each page will have 24 student photos. The photos will be arranged in a rectangular display with the same number of photos in each row. How many ways can you arrange the photos so that there are no more than 10 photos in any row or column? How can I do that?
So we're trying to like
You're working on your school yearbook. Each page will have how many photos?
24 student photos.
Okay, so there's 24 total photos, correct?
Mm-hmm.
No? Okay. The photos will be arranged in a rectangular display with the same number of photos in each row. How many ways can you arrange the photos so that there are no more than
No more, yeah.
10 photos in any row or column? So what do you think we need to do to try to figure this out?
Do we have to make an inequality?
Nope. No. It wants us to list all the ways we could create rows and columns to arrange the pictures of 24, but you won't have more than 10 in each row or column. So how can I figure that out?
How do you divide?
Well, kind of. What do you mean by that, Bree?
How many rows?
Okay, that's a good idea. So she wants to take the 24 students and divide it into groups of rows and columns, okay? But how can we do that?
Divided by 24 by a number?
What do you know about the number 24?
It's
It's
Right.
6 times 4.
It's 6 times 4. What else is it?
2 times 12.
2 times 12. What else is it?
8 times
8 times 3.
8 times 3. What else is it?
a number
1
times
times
number.
24.
1 times 24. Anything else go into 24?
2 times 12.
I already
That's right,
said
yeah,
that.
right.
We said
Sorry.
1 times 24, 2 times 12, 3 times 8, 4 times 6, yes?
Yep.
Okay, so there are 4 possible ways that you could create this, right? Well,
Oh, so those are the 4 ways?
no,
you do
those
it?
are not the 4 ways, but I'm telling you there's 4 ways.
Oh.
What does it say in the instructions? Your photos,
Oh.
so that there are no more than 10
just
photos in
10.
any row or column. If I
Could
go
you-
to this one, is there more than 10 in a row or column?
Yeah.
Yeah, so I
You could-
can't use that.
You could use 6 and 4 and 8 and 3.
Right, I can't use this one. But I told you there's 4 ways. So
There's
listen,
more numbers.
You can use a 6x4, or I could do a,
4 by 6.
4 by 6. Oh.
I can do a 8x3, or I can
3
do
by
a,
8.
and so now I have 4 ways of arranging those photos.
Oh.
my God.
So in order to
Okay.
do stuff tonight, you're going to have to break it down into all of its factors.
So none of the like 1 times.
Anything that had more than the number 10 in it, we cannot use.
Okay.
Okay, because it said we don't want more than 10 photos in each row or column. Okay, so you're going to have to start factoring. That means you gotta start knowing math facts. Okay? Remember how, did you guys in elementary school have all those little timetable charts?
Yeah.
Yeah, you better hope that you remember those.
I remember those.
Do you remember this?
Yeah.
And then we're gonna talk about another way to do this.
Answer the question.
Okay, so we talked about a prime number, we talked about a composite number, okay? What is a prime factorization? Use some common knowledge here. What's prime mean?
1 or like
It means like,
single.
it means that it's a number that can only be multiplied by 1 in itself, yes? A prime number. So if something's a prime factorization, okay, when you write a number as a product of prime numbers, you are writing the prime factorization. Okay? When you write a number as a product. When you write a number as a product, of prime numbers. Okay, so when you write a number as a product of prime numbers, it's called the prime factorization. Then there's one other term we gotta talk about, which is a factor tree. Do you guys remember what a factor tree is? I love factor trees personally. And we're gonna do lots of them. Okay, a
Lovely.
factor tree is writing the prime factorization of, it's how to write the prime factorization of a number.
Oh.
Okay. Now, we're gonna do some factor trees. What do you say?
Okay.
Okay.
Yeah, I don't mind.
Meaning, we want to get the number that I give you down to all of its prime numbers, okay? That means every number that it gets down to should only be able to be multiplied by 1 and itself, okay? So let's talk about the number 630,
Oh, shoot.
okay? Now, I start small because that's how I think. But what can go into 630 without a calculator? No calculators.
215. No.
It's small.
5 can go into it.
No.
You think 5 can, yeah, 5 can definitely go into it because it ends with a 0, right?
Yeah.
Okay, let's take 5 into it. If I take 5 into 630, how many times does that go into 630? 5 goes into 6 once, right?
Yeah.
And then you get 13, so 2 for 10, right? So if I do 630 like this and I divide by 5, right, I get 5, or I get 1, 5, I get 1, 13, which is 2 for 10, right? And then 30, yes?
Yeah.
Which would be,
6.
so 126. What else can go into 126 now?
2 or 3.
Okay, 2, let's do 2. 2 goes into 12 how many times?
6.
6,
Yeah.
and 2 goes into 6 how many times?
3.
What goes into 63?
Wait.
Um,
9.
9. Okay, 9 and what? 9 times what?
7.
Okay, what goes into 9?
3.
3 and 3. Can anything go into 5?
no.
Can
What?
anything go into 2?
Yes.
Yes.
No?
No.
2 times 1.
Yeah, these are all prime numbers.
Okay, now.
5, 2, can anything besides 1 and 3 go into 3?
2
No.
times
What about
1?
7?
No.
What? I got
No, so here's what you would write. If it says, write the prime factorization of 630, okay? And we do it this way, the way we would end up writing it is we would take these numbers. I have a 2, yes?
Mm-hmm.
How many 3s do I have?
2.
So you have times 3 squared,
Oh.
okay? Then we have a 5, we just put them in order from least to greatest. And then we have 7. So the prime factorization of this, of 630 is 2 times 3 squared times 5 times 7. So when it's asking you to write the prime factorization of something, you're going to show me a factor tree. And then you're gonna order them from least to greatest and just multiply them by each other. If there's a repeat, you put a squared. If there's 3 of them, you put a
Cube.
cube. Okay, and keep going and so forth.
Yeah.
So cube for 3 and then retree for 2.
Yeah.
Alright.
Okay, so that is a factor tree. Let's do one more, and then we're gonna do one where it also has letters and not just numbers.
No. Wait, what?
We'll look at it,
Letters?
letters and not just numbers.
What?
I don't know what you're talking about.
I know, we're gonna look at it in a
It's
minute.
like all A's going.
Okay, let's try this.
It's a factor tree?
Yep, let's
Okay.
try 180. What can go into 180, people?
5.
Okay, 5 goes into it how many times?
Wait.
5 goes into 18 how many
Oh.
times?
Oh, does it go in?
3, with a remainder of what? What's
3.
2. No,
3.
3.
And so then that means 30, so 5 goes into 30.
6.
So then what's that break down into?
6 and 6.
6 and 6. And what does 6 break down into?
2 and 3.
2 and 3 and
2 and 3.
Okay, so we go to line them up. There are how many 2's?
2.
So it's 2 squared times how many 3's?
3 squared. 3
Three.
cubed. Or 3.
No.
No, it's 3
There's
squared.
3 squared, so there's only 2 of them.
Ha 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 ha.
Times,
5.
yep, beautiful, times my 5. And that's my prime factorization. Okay? You are going to have to show me a lot of work on your homework tonight. If you do not show me factor trees and work, you get 0 credit.
What am I talking about?
And listen, I want you to try to do this without a calculator.
Okay.
In fact, no
Don't look
calculator.
at me. Don't look at me.
No calculators.
So
Okay.
no calculators at all in the homework?
No calculators on the homework. You can totally do this without it. Okay? Which means you might show me some long division on the side too.
That's okay.
I need us to get used to these numbers. Okay, now we're gonna factor something called a monomial. Do you know what a monomial is?
No,
What's a
no,
monomial?
I have no clue what you're talking about.
Sounds like an artwork.
Let's put that
Sounds like
definition
artwork.
over here with the rest. Monomials. Okay, a monomial is a number, a variable, or a product of a number and one or more variable. It's a number. If I could spell that would help. It's a number, a variable, or it is the product of a number and variable. Or a product of a number and variable, okay? And one or more variables raised to a whole number powers. Okay. Let's fix this. Okay, so here's what a monomial is. It's a number, a variable, or the product of a number and one or more variables raised to a whole number power. Meaning, this is a monomial. 28xy cubed. That's a monomial. Okay, we're going to have to factor monomials as well. Okay, factor the monomial. When something tells me to factor a monomial, guess what I'm gonna do? I'm gonna take each part individually and factor it. Like I'm gonna factor the number, then I'm gonna factor the x's, then I'm gonna factor the y's. So let's focus on the number. What's the number?
28.
Can you factor 28 for me?
Yes.
What does 28 factor into?
7 and 4.
7 and 4, yeah.
7, 4, and 4 is?
2 and 2.
So it technically factors to 2 squared times 7, yes?
Wait, there's one more.
What?
Yeah.
Wait, yeah, 14 times 2.
Okay, if I do 14 times 2, what's 14? 7 and 2, right? So it's still 2 squared times 7.
Oh.
You can break it down differently, it's fine. We're looking for
I
the
can't see
prime
the
numbers.
definition. Sorry.
Well, wouldn't you have to like add in the 4 as well?
No, stop. Is 4 a prime number?
No, never mind.
When you are factoring, you're always going down to prime numbers,
A lot to remember.
okay? So I factored the 28. Look at the x. How many x's are there?
1.
So it's 2 squared times 7 times x. How many y's are there?
1. Bless you.
3, because it says y cubed, which means it's y times y times y. So when I am factoring that, I simply break it down to y times y times y. So the factorization, okay, the factorization of this is 2 squared times 7 times x times y times y times y.
Oh, so you can't put Y's.
Cubed, yeah.
Cubed.
Because they want you to know that there's 3 there. So the numbers you can square and cube, the letters you cannot. You have
No,
to
that's-
unsquare or uncube them.
That's great.
Alright,
Okay.
that's what I remember.
Okay. So when I'm doing numbers, I'm breaking it down into the smaller portions. When I'm doing letters, I'm breaking it down into the smaller portions as well, okay? Now, let's look at another one. Let's
Oh,
try,
that's all you have to do?
yeah, that's all you have to do. Let's try another one. Let's try this one, 36 s to the 4th t. Okay, what do we need to start with first?
36.
Okay, so let's break down 36. What's 36 break down
That's a
into?
street.
12 and 3.
12 and 3, or 6 and 6, right? What's 12 break down into?
2 times
2,
6.
6, or
2 and 6, or
Or
4 and 3. And what's 6 break down into?
2 and 3.
3.
Okay, so how many 2's do I have?
2.
So it is 2
2,
times,
6 and 3.
no, times
3 squared?
S
3 squared,
yeah.
times what now?
S times S times S times S times
Oh shoot. S times, oh wow.
Beautiful, there's your prime factorization of that. So monomial just has numbers and letters together, and you're just factoring it out, okay?
Just give me water.